Alright, so we have here is another three variable system, three equations, three unknowns, and the goal is to find x, y, and z. Now remember, the first intermediate goal, I guess you could say, is to get two equations, two variables, because we know how to solve that. So through elimination, we're able to eliminate variables. Now, so the first thing we do is look at the system and say, well, which variable is it going to be easiest for me to eliminate? Now I look at that and we could do the x's, we could do the z's. I mean, it really doesn't matter. It's just a matter of how much work you're willing to do. I like the fact that there is a single x in the first equation, so I'm going to use that. So we're going to eliminate x until we get two equations in y and z. So in order to do that, I'm going to look at the first two equations, and I notice I can multiply the first equation by -2. And that gives us -2x plus 8y minus 6z equals -10. And I'm going to put that with the original second equation. So this is basically, well, so I'm going to label these equation 1, 2, and 3. So we're using 1 and 2 here. So add them together. X's go away just like we planned. We have 13y minus 10z equals -7. I'm going to put that equation in a box because I have a feeling I'm going to be using that a little bit later. So now we're going to use equations 1 and 3 to eliminate x again. Again, I want to take advantage of that 1x. You don't have to. You could use equations 2 and 3. But if I use 1 and 3, the magic number I have to get is a -3 in the first equation. So I'm going to multiply the first equation, I keep switching colors here, by -3. And that gives us -3x plus 12y minus 9z equals -15. And I'll say this now, be very careful and methodical when you're doing these operations, because one small mistake in the middle of the problem can really lead to disaster. If one number is off, it could really throw off the answer that you get and really make it a nasty answer. So adding those together, 3's go away. So we have 20y minus 7z equals 6. So there's our second equation. So now I'm going to bring these together and figure out what to do from here. So you have 13y minus 10z equals -7. 20y minus 7z equals 6. All right, well, we could do elimination, we could do substitution. I like to stick with elimination just because that's where we started. So I'm going to multiply each equation by something so that the numbers, the coefficients of one of the variables cancel out. You can pick whatever you want to. I'm going to go with the y's just because they're first. And what that basically means is I'm going to multiply the first equation through by -20. And I'm going to multiply the second equation by 13, just so I know I have the same number. So that gives us, I'm just going to draw an arrow and go down here because I need more room. So we have -260y plus 200z equals 140. And then 260y minus 91z equals 78. Those cross out. So we have 109z equals 218. That looks scary for a second. When you divide both sides by 109, we get z equals 2. Who knew? Okay. So now the whole process is, now we found the value of a variable, we should be able to go back to the other equations and find the others. Notice just above us, we have equations with just y and z. So if I use either one of those, I can find y very easily. I'm going to pick the one that's closest, this one. So we have 20y minus 7z equals 6, which means 20y minus 7 times 2 equals 6, which means 20y minus 14 equals 6, which means 20y equals 20, which means y equals 1. Fabulous. We have z and we have y. Now we'll go back and get x. So I got to pick an equation that has an x in it. So coming back to the original, I really don't have one that's nicer than the others. I guess the first one, honestly, just because it only has a single x. So x minus 4y plus 3z equals 5. And I'll substitute what I know, which is 1 for y and 2 for z. So you have x minus 4 plus 6 equals 5. And that means x plus 2 equals 5, which means x equals 3. So the solution to our system as an ordered triple, x comes first, y comes second, z comes last. And there it is, the solution to our system, which means if you substitute these values into each equation in the system, it will satisfy each equation all at the same time. So there's our solution. Thanks for watching.